Here we have a circle, a radius, and a tangent to the circle. A tangent to a circle is a line which just touches the circle at one point. The angle between a radius and a tangent is always 90 degrees. We can see as we move the radius around with its tangent, this angle remains 90 degrees all of the time. So here's a circle, a radius, and a tangent to the circle. Remember, a tangent is a straight line which just touches the circle at one point. The angle between them is always 90 degrees. And if you're asked to state a reason, just simply write down tangent property. There is a second tangent property. If we have a point external to the circle, then we can always draw two tangents from that point to touch the circle. If we call this point of contact A and this one B, then it's a fact that TA is equal to TB. The two facts can be combined. We know this will be a right angle, as will this. This length is equal to this length, and that's a tangent property. Both of these lengths are radii, so they're the same length as well. So the quadrilateral formed here is a kite. Furthermore, if these two angles are 90, that means they add to 180. The angle sum for a quadrilateral is 360. It follows that the other two angles must add to 180 degrees. We know the angles in a quadrilateral add to 360. As an example, consider finding A here. If this angle is 220, and we know the angles all the way around a point of 360, it follows that this angle must be 140 degrees. If this is 90, and this is 90, using the tangent property, these two must add to 180. It therefore follows that A is equal to 40 degrees. Here's a second example. We want to find A again. Here we have an arc of the circle. We can see this angle stands on the arc at the circumference. And this angle stands on the arc at the center. This angle here is twice the 65 degrees, so it's 130 degrees. We then know that using the tangent property, in this quadrilateral this angle is 90 and this is 90, so the 130 in the A must add to 180, giving us that A is equal to 50 degrees. In this final example in this section, we want to find the distance OT. Using a tangent property, we know that this angle here is a right angle. So we have a right angled triangle, and this is the hypotenuse. We know Pythagoras' theorem, a squared is equal to b squared plus c squared, where a is always the hypotenuse. The hypotenuse here is OT, so OT squared is going to be 5 squared plus 12 squared, which is 25, plus 144, giving us 169. It follows that OT is equal to 13 centimeters.